So this will be our last notes for Chapter 5. And this is going to be Lesson 5-6, and it's on inequalities in two triangles. And today we're going to be looking at something called the hinge theorem. We'll go over that in a minute, but I just want to remind you, when we were talking last chapter, we were talking about the triangle inequality. And an inequality, again, is something where it says this set of numbers or this mathematical statement is greater than or less than this other mathematical statement or number. We can use that for triangles by saying this theorem, the triangle inequality theorem, that if we looked at side AB and we added BC to it, that those two sides together are always going to be greater than side AC. And we can take any two sides of these triangles and they're always going to be equal than the other side. We can also use that to figure out the range of, if we know two sides and so on, and we know that they're going to be greater than another side that we don't know, we can also use that to figure out a range. So let's look at these notes for two triangles now. So we're going to start off with a theorem here. It's kind of long, but I wrote it all out. It's in your book if you want to check it out. So the hinge theorem says this. It says if two sides of a triangle are congruent to the two sides of another triangle. And if we just look here, here is that condition. So we have this triangle ABC, and we have triangle FGH, and look, we got this side is congruent with that side, and AC is congruent with FH. We got the first condition. So it says if you have that condition, and it says and the included angle of the first is larger than the included angle of the second. So we look here. This first triangle has an included angle of 43 degrees, and then this is 30, and the included angle is, we got side, angle, side. So that's really what it's talking about. So this angle, included angle, is greater than the second one. Then we can assume this. Then the third side of the first triangle is longer than the third side of the second triangle. So then we can say that BC is longer than GH. And again, we're just saying we have two sides of two different triangles that are congruent. AB, FG, and AC, FH. And then if we know that this angle 43 is greater than this angle for this triangle, we can then say that this side BC is greater than GH. And I kind of wrote it out here. These sides are congruent. This side is congruent. And we can just say the measure of angle A is greater than the measure of angle F. So that's kind of what the hinge theorem says. So then we'll have the converse of that theorem. And this says, kind of a little bit different, it says if the two sides of a triangle are congruent to the two sides of another triangle, so again we look, we have that condition right here. We have triangle ABC and DEF. AB is congruent with DE, and AC is congruent with DF, so that's the case. And then it says, and then the third side of the first triangle is longer than the third side of the second triangle. Okay. Then because of that, so if we look here, we could measure these, right? You can kind of see this side BC is longer or greater than EF. So if you have that condition, then that means if we have all those conditions met, then the included angle of the first triangle is larger than the included angle of the second. So here we see 47 degrees, and here we see 30. So that is the case. So we can, if this is the converse of the hinge theorem, so we have these two sides that are congruent, they're the same. But then the other condition we need is for this side to be greater or longer than the side of the second triangle, and it is. You can obviously see that here. Okay, and that tells us that this included angle for the first triangle is always going to be greater than the included angle of the second triangle. And now we can use these kind of things to help us solve for unknowns. So here we're going to do that. So we have this little scenario, and I've kind of written the scenario out. Whenever you do these problems in your book, you want to make sure you have yourself a diagram. Draw one for yourself so that you're following and making sure that what you're reading and that you're writing the same thing out in a diagram. Okay, so let's read this scenario. So it says two paintball teams leave, and they're leaving from the base camp right here at this dot. they leave the base camp and head west. One heads west and east. The other one heads east. Okay, and they both go the same distance, 7.5 miles and 7.5 miles. I don't have that in here, but that's true. So they both go 7.5 miles. And Team A, we'll call this side over here Team A, they turn right at a 35-degree angle. And Team B turns right. This would actually be left, right? Turns left, or north. We actually get north. So Team A turns right or north, we could call it. Let's just fix that up. So one turns 35 north, the other one turns 40 degrees north. Okay? And they both travel 5 more miles. So here we get to 5 miles. Okay? Which team is the furthest from the base camp? So we can kind of use the hinge theorem to figure this out. And how we do that is we look for congruent things or sides. And here we have both of these are 7.5, so we'll put a line for that. And then we need another side congruent. Looks like 5 miles and 5 miles. So we'll put 2 there. Okay. And then we just need to know included angles, because we'll know if the one included angle is greater than the other included angle, and they have 2 congruent sides, then the last third leg is going to be longer than the other. So we need to just figure out the angles here, and we should see this one's 35, this one's 40. So this one, the entire angle is 180, so we're going to see that this should be 145 degrees. And then this one should be the total is 180, so we take 180 minus 40, and we should see 140 degrees. So by the hinge theorem, we should see that we have these sides congruent on opposite triangles, these sides are congruent on opposite triangles, and the included angle is greater than the one on the right, and the one on the left is. Then we can say that AB, side AB, is greater than, we'll just call this B, and we'll call this C actually. So we'll say AC is greater than BC. And that's the way we can use the hinge theorem. There's one other thing we can do. So we can kind of use algebra as well. And here we have a couple triangles. And we have some sides. We have JE, we know is 11. We have EG is 9. And we know that these sides here, J to H is congruent the same as H to G. We also have an angle here, 65 degrees. And then we have the angle here, and we don't have it, but we have an algebra, 6x plus 5. We have a statement, an algebraic statement, whatever that angle is equal to. And then we also have this reflexive property going on here. So they have a shared side. So we know that the EH for this triangle is equal to the EH of the other triangle. Okay? And we might say, we might ask up a question like, so what's the possible values for x? What could x be equal to make this condition true? And we look at the knowns first. So for this triangle, let's see if I can keep this in here. So for this triangle, we know a couple things. We know JH, which is right here. JH is congruent with GH, so the same. That's noted in the diagram. We also know JE, this side, is greater than EG. Okay. And then we also know that EH and EH, these two lines right here, are the same. Okay. So if that is the case, then we can figure out by using something called the thing we just learned today, the converse hinge theorem, we can figure out what are the ranges of the 6x plus 15. And we can do that by looking at congruent sides. So we know these are congruent, right? We know these are not, JE and EG. Well, we know this shared side actually is. So we'll call that 2. So here we have these sides are congruent. EH is congruent for both triangles. So then we need to know what is this range for this. If we look at the third side, we know that this one is greater, 11 is greater than 9. So this angle, GX plus 15, should be greater than 65. So we can then state that by measure of angle JHE, right here, is greater than measure of angle EHG. Okay? And that's the converse hinge theorem, just restating it there. So then we can set this up as a inequality. We can also at the same time do something else. We also know that these two angles right here, they cannot be greater than 180, right? So then we can also say that this angle, JHE, the maximum it can be is less than 180. So then we can then say the measure of angle JHE is less than 180. So then we can then again, 6x plus 15 is less than 180. And then we can solve these, okay? And we can then say 6x, we can minus 15 from both sides, is greater than 50, okay? And then we can divide by 6, and we'll get x is greater, let me pause this and do the math. So we do all the math here, and we divide by 6, and we get x is greater than 8.3. That's going to be your lowest value. And then we go the greatest value, so then we're going to do the 6x plus 15 is less than 180. So then we're going to go 6x, we're going to minus 15 from 180, and we're then going to get 165. We're going to divide by 6, and we're going to get, let me do the math, pause it here. So then we end up with that when we do the math, x is less than 27.5. So then if we want to figure out the range, so x is greater than 8.3, that's repeating, 8.3, repeating, and that's less than x, and then x is less than 27.5. We could then plug that into the equation to see what our range is. So let's, so here we would just take 8.3 times 6x times 6 plus 15. Let's do that math. So then when we plug these in, you're going to see that really when we plug in that 8.33 repeating rate, you get 64.9 is less than x. So x at least has to be 65, and then it has to be less than 180 when we plug in the 27.5. That's kind of how you use algebra and the hinge theorem. And that's our notes, our last notes for chapter 5. And add these to your notebook. We'll do a couple check your understanding problems in class tomorrow. We'll work on the homework and maybe start on the review as well. Add these to your notebook. I'll see you in class.